Hello, everyone, and welcome back to the second day of the Healthcare NLP Summit 2023. I'm David Talby, CTO at John Snow Labs, and I'm thrilled to be here today with this amazing NLP community. Yesterday, we heard in 17 sessions about state-of-the-art large language models and how NLP is leveraged to predict suicide risk, provide patient-focused solutions, monitor adverse events, and much more. In the next 4 hours, we'll continue the conversation about some of the latest research and NLP best practices, real-world case studies, and challenges of applying state-of-the-art NLP in the healthcare and life science industries. You will hear speakers from Google, MIT, the Berlin University of Applied Sciences, the University of Pittsburgh, John Snow Labs, Omni Health, Reckitt, and many more. And I'm sure we will all learn a lot. For those who did not attend yesterday's events, I'd like to go over some housekeeping items to make sure you're familiar with the conference platform and the amazing features that are at your service during this event. Please note that there are 3 virtual stages at the event. After the keynote talks, 3 sessions will run simultaneously. So check out the schedule on the menu bar in the reception section to decide which one you'd like to attend. All sessions will be available on demand for 2 weeks after the event, so no worries about catching all of them today. They will be published here on the platform in the replay section right after the event. Each stage has a Q&A panel where you can ask questions throughout each of the sessions. Use this opportunity to drop your comments or any questions for the speakers or other community members right in the chat. Get a chance to meet like-minded NLP practitioners using the networking feature of the platform. You can send other attendees a message or meet them randomly for short, fun video sessions. If you would like to connect with John Snow Labs, visit our booth and we'll be happy to get in touch and answer any questions you may have. I look forward to the second day filled with excellent NLP content, and without further ado, let's kick off and introduce the first keynote. The first keynote speaker today is Veysel Kocaman, who is the head of data science here at John Snow Labs. In his talk, Veysel will present a detailed comparison of the state-of-the-art large language models and the pre-trained deep learning models from Spark NLP for healthcare on various NLP tasks. I'm super excited to share these results with you. Thank you for joining us, and take it away, Veysel.
Hello everyone, welcome to Healthcare NLP Summit. This is Veysel, Head of Data Science at John Snow Labs. I am the one leading the Healthcare NLP team at John Snow Labs for the last few years, and today in this keynote, I'm going to talk about the large language models on clinical and biomedical NLP benchmarks. During this talk, I'm going to start with a little bit preview of the large language models, especially in the clinical and biomedical domain. And then I'm going to talk about the risks of the latest GPT-based models when we want to use this in the clinical settings. And then I will do some benchmark analysis between the GPT 3.5, 4, and Spark NLP pre-trained models. So, as you know, all this GPT family models, right, started 2019 with the first version of the GPT. And since then, there are more than 100 different large language models trained and then released by different companies and research institutions, both in open source and in the license domains. So briefly, what large language model is it's a model, it's a neural network with around like usually 1 million to billion parameters trained on large amount of unlabeled data text using self-supervised learning techniques. And then the first advent of LLMs are around 2018, and especially for the last 2 years, there's a big interest and then trend going on to train large language models as using the entire available data out there. So especially for the last few months since the advent of ChatGPT, which is kind of introduced that this LLM, the magic of LLM to the entire world, because right now it is something that everyone can use. Even the 12 years old, 5 years old kids can even use ChatGPT easily with no expertise, because it's a chatbot framework that can easily communicate through some browser, right? Of course, you cannot deploy on-prem. It's an API that you need to communicate. Since ChatGPT, there are different similar variants, especially the Llama is a good one released by Meta, and then the Alpaca, which is the lightweight version of the Llama, and then the last one, which is released a month ago, GPT-4. Right now, that is the best LLM considered out there right now. So of course, GPTs are a great productivity tool. Yeah, I use it. Like many people, many of my colleagues, my friends are using this on a daily basis. It's a great productivity tool if you are using it right in a right way. If you are trying to extract some knowledge, of course, like truth and correct answers for specific questions that you want to answer, of course it may not be perfect, because always you need to check its veracity, right, its truthfulness. But it has started to be integrated into many different workflows in the office applications, in mobile applications. There are plugins written every day, and then there are very cool application like instant transcribing the patient notes during clinical visit. These are some clinical use cases. And we can easily say, just like Wall Street Journal says, AI has its iPhone moment right now with the advent of ChatGPT. And it can even write code in a junior level, and sometimes we see that it can even write code in a senior developer level. And of course, the media, social media, journals, and newspapers are all talking about this, and then some people are, of course, saying negative, like it is raising concerns. They claim that it is destroying the humanity and then the community. But there are some concerns, of course. There are some bright and dark sides. But right now, it is something that everyone talks about. So we are all fully aware of this. But we need to know its reflections. So on the domain that we are working right now in the healthcare domain. Because the dark truth about this is, when we are working in a highly complaint environment that we deal with PHI data every day, we value precise abstraction and then the truthfulness, right? And then ironically, the more larger the model, the less truthful they are. So on this chart, you see this. The smallest version of GPT-3 has 350 million parameters, and its truthfulness is lower than 40%, which is the highest level, by the way. But its largest version, 175 billion, it is around 20%. The funny thing is that when GPT-2 is released in 2020, it was considered too dangerous to release that OpenAI didn't release the larger version. It only released the smallest version, by the way. But right now, we are not even using GPT-2. We are still using somewhere, of course, in some applications, but compared to GPT 3.5 and 4, that there is a huge performance improvement over there. So, and after GPT, there are some other open source version of the GPT for GPT variants developed, like GPT Neo, GPT Neo X, GPT-J, etc., Neo GPT, and they have different level of truthfulness as well. But in average, the larger the model, the less fruitful they are, because they are language model. They are learned on a large amount of data with no label. So, and then that data comes from everywhere right now on the data that on the internet. It may be, so there are tons of unreliable information out there as well. So ChatGPT, when it comes to truthfulness, ChatGPT it's still its accuracy is around 43%. There's in their technical report, GPT-4 technical report, like released a month ago, a few weeks ago. Even the best version of GPT-4 is still answers more than 40% of the questions incorrectly. So, and it is the best version of GPT-4, by the way. The base version with no instruction, zero prompt, it is still 30%, which means that it answers 70% of the questions incorrectly. Then the like reinforcement learning human feedback version, which is the Chat GPT version of GPT-4, still answers 40% incorrectly. This is quite alarming, by the way, which means that you may never be sure, because you are trying to remove the human in the loop, but now you need to put the human in the loop again to check the veracity of all the information that is extracted. There is another nice paper released a few months ago again. By the way, every week there is a new paper coming up again about ChatGPT and GPT-4. So just today there are more than 10 different papers that I saw. I could only read one of them. So this is released 2 months ago. They were trying to evaluate if ChatGPT could be a natural language solver, and then they claim that yes, it could be a natural solver on certain tasks, especially on the common sense reasoning, symbolic reasoning, logical reasoning. Like this kind of reasoning tasks, ChatGPT can do really well. It's comparing to ChatGPT itself, 3.5 version and fine-tuned version. Fine-tuned is another LLM fine-tuned on that specific task. So which means that the chart that you see here for ChatGPT and ChatGPT 3.5 are zero-shot performance. So on the smaller tasks like NER, name identity recognition, and summarization, ChatGPT is still not doing very well. There are some reasons that I'm going to unpack later, by the way, but the short answer is that name identity recognition is there to solve certain problems in the next stages. It's not just NER, what we are trying to achieve. It's not just the entity that we try to extract. So each name identity recognition model needs to be developed and designed in a way to solve certain problems, to extract certain entities given the domain. Because I might say entity A, but you can consider the same entity as an entity B. So in that case, the model cannot answer this because these are all zero-shot or fifth-shot models. And then, as you can see, 2003 CoNNL dataset in NER, it is doing really well, really worse. By the way, the metrics is around 53%. So such a big model can achieve 53% accuracy on such a simple task, and specific libraries that is like including Spark and NLP, we can easily hit above 95% on the same data set, by the way. But there's another reason for it. We call it prompt, right? So they only give the one prompt with no shot. So it's just a zero shot right now. It just asks the model to identify person, organization, and location entities, but they didn't explain in their prompt what kind of, like, what is person, what is organization. And so we call it fifth shot if they would give some examples when they are writing their prompt. So in the reasoning task, ChatGPT version is doing well compared to the other large language models like UL2, which is the base, which is another variant of FLAN T5, Lambda, Codex, Palm by Google. So if you when you compare to ChatGPT and its variant by OpenAI, it's doing really well on the reasoning tests. But when it comes to human level exams, college level exams, some bar exams, like board exams, GPT-4 is doing, like, breaking all the records right now and then exceeding human level performance, according to this technical report, by the way. Of course, this technical report is correct. We want to believe this, and it's probably correct. But I try to dispute if this is what happens if right now GPT-4 is doing like 5 times better than GPT 3.5 on the bar exam. And it is right now exceeding all the human baselines on all these exams. Maybe it's time to consider how we evaluate the human intelligence, why we run these exams, why do we have these exams. Maybe we shouldn't evaluate the humans for certain topics in that way, if right now GPT-4 can easily pass this with zero shot. So if you want to check the capabilities of GPT-4 on medical challenge problems, there are certain benchmark datasets like MedQ&A, medical Q&A dataset, PubMed Q&A, PubMed articles based question answering models, medical multi-choice Q&A models, Q&A datasets, and so on. So its performance, even in the non-English data set, its GPT-4 is doing really well, like around 80%. The closest competitor was like GPT 3.5 and Palm. The Palm was about 60%, which was specifically there's a Met Palm version of the Palm, and GPT-4 is right now above 80% with 5 shot, and then the 0 shot of GPT-4 is even doing better than 5 shot of 3.5 on these medical exams, on these medical data sets actually. So this is quite impressive, by the way. So it's clearly show the capabilities of GPT-4 on medical challenge problems. But again, why do we have these data sets? Why do we have, are they representative of the problems that we are actually solving in healthcare industry right now? No. So let's move on. So when we check another popular exam, US medical license exam, GPT-4 is doing about 83%. So in average, like the previous GPT 3.5 was around 63, which was still above the threshold of the passing grade. Now it is doing much better than the human with 0 shot, which means that with 0 shot, with no instruction, just asking the question and then expecting the answer without explaining anything, GPT-4 can pass this exam, which is a highly competitive exam, which is highly competitive exam that all the medical doctors need to pass to practice, right? So its competitor is MedPalm, which is released by Google, which is specifically trained on the medical data sets. It is the upgraded version of the MedPalm, which is released a few months ago, by the way. When the MedPalm is first released, it gave 17% boost compared to its closest competitor, which is PubMed GPT. Now MedPalm 2 is giving 18% more boost. So this is quite amazing, and it is exactly the same score, around 85, 86 compared to GPT-4. But they, on their technical reports, they say that they tested this model on 14 criteria, but it failed to pass their criteria, so it's still not a model that can be used safely. When we say safe, of course, your data might be at risk due to vulnerabilities of third-party APIs and libraries. Because right now, ChatGPT and GPT-4 cannot be used on-prem, right? You cannot deploy it. You cannot probably afford deploying it on-prem. There are only a few institutions probably in the world right now that can manage and deploy this kind of large models and then serve millions of people. Even if for your own use case, yes, but it's still too much money and cost, and then expertise needed over there. And then since we are talking about the vulnerabilities, even the high school kids are using this, and then there are different websites that is explaining how to unlock the true potential of ChatGPT with different jailbreak techniques. And then even OpenAI itself shut down the ChatGPT a week ago, just a week ago, March 24th, because of a bug in an open source library. That open source library is Redis, by the way. Redis is an internal library, like it's an open source library they use to serve their customers for through their API. And then they say that they had to take it down for a few hours, and during that period, ChatGPT, it was possible for some users to see another active user's first and last name, email address, payment address, the last 4 digits of credit cards, which means that this is quite serious, right? But it is right now. If you use some third-party libraries in your API, you are also responsible from that libraries, right? So which means that it could inject many vulnerabilities, and then there are plugins coming in as well. So plugins can have their own vulnerabilities that can infiltrate into your environment when you send your data. You may never know what's going to happen. So those are all the risks that you need to pay attention when you are using this model. And according to another survey that I read last month, around like 20% of the people, like 2 months ago, by the way, are sharing their proprietary data, company data, to OpenAI ChatGPT servers. So which means that they are sharing their internal data, sensitive data with third-party APIs right now. Just today, I'm recording this talk at March 13th, by the way. Just today, there's a new paper evaluating GPT-4 as a AI chatbot for medicine. So there's a one example here that I took a snapshot, the one example incorrect output. So the human is trying to communicate with the chatbot and asking questions about a specific medicine called metformin, and then ask ChatGPT, like GPT-4, how come it knows so much about this drug, and then it just fabricates some answers and says that he has a degree, a master's degree in this domain, and then he says he's just making fun and just trying to sound impressive. This is just, this is just fabricated like fake information over there, and you may never know if it is telling the truth or not. So, and then at the end of the paper they say that they are not able to evaluate the normal, like layman, like a simple human being cannot evaluate the true intelligence, general intelligence and usefulness of such a tool. And then they don't know how to trust GPT-4, and reader need to spend time to verify the veracity of the information shared by that chatbot. This is quite alarming, by the way, because you are trying to remove the human, but now you need to put the human back in the loop to check every information that is returned by the chatbot, which is quite impossible. And then so fact checking and proofreading is needed, and then they still evaluate to what extent GPT-4 can accomplish these tasks. Of course, in a few months, there will be new version. Maybe while you are watching this recording, there will be a new version of GPT, maybe released in 2 weeks, in 1 week. It happens, right? So, but their release cycle is quite short, and then they are improving their tool again and again. And there's also the open source variant of GPT, and GPT-4 is being released every day, which we are also working at Johnson Labs right now. We are working on our own solution right now. The reason for this is that because the data set that these models are trained are open source, internet openly available data set. So the ratio of the medical data set in these resources are very low because we don't share our PHI data openly, so that these LLMs do not get to see to these data sets while they are being pre-trained. So that's why their clinical relevance are low. So the information returned by these language models are the level of truthfulness might be really low compared to the other domains, which has no PHI issue. Now, in the last few minutes, I want to compare ChatGPT versus Spark NLP for healthcare, which is hosting more than 1,000 clinical pre-trained models for name data recognition, to the assertion, to the relation extraction, to the all the transformers. Right, we have more than 1,000 pre-trained models available with a few line of code. I can summarize the differences in 6 topics. The first one is accuracy, because the models that we trained are usually created data set, trained on a created data set, and perform better rather than attacking an entire problem from one angle. We specifically attack each problem one by one, so that's why we have 1,000 models out there. Its performance, which I'm going to show in the next slide, is way better than ChatGPT. Its speed, because it's using Spark ecosystem, right? It is faster than ChatGPT in processing large volumes of data, and it is most cost effective, right? Because you don't need to pay for every token. You only pay for once for a license. You can customize. Customization is important because it needs to be explainable, and if you need to be able to change the stages and then the rules that you don't like in ChatGPT, you cannot do this. It's a closed book, right? So you just send your answer, and then send your question, and then send your prompt, and then get your answer. But in Spark NLP pipelines, you can change every stage. You can add new rules. You can drop some rules, and then you can customize till you achieve what you need. And so it's quite transparent. And then the most important one is on-prem. All these models can be deployed on-prem with no internet connection. But in ChatGPT, let alone deploying on your on-prem, the only way to use this is through API. So which means that you need to share your data with their API. So those are the entities and tasks that we applied while doing our experiments. So for name data recognition, we picked 10 different entities. For entity resolution, we picked 3. terminology, text classification we speak to like gender and adverse track. In entity resolution, we only did ICD-10 because SNOMED and Ariston, ChatGPT is not able to return proper answers, so it would be an unfair comparison. It's just fabricating answers when it comes to SNOMED and Ariston. So that's why we had to drop them and only run ICD-10. So how we run this test? So first of all, we created a detailed prompt, as you can see on the left-hand side, and then we asked these questions to the bot. It's one shot right now. We created an entire prompt, just like we instruct our own human abstractor. We sent this prompt to the model and then ask it to extract problem entities. And as you can see on the right-hand side, Spark NLP can achieve around 90% accuracy on one entity, while ChatGPT can only achieve around 76%. Uh, so when we do this for the rest of the entities that we picked, as you can see, the Spark NLP is always doing like between 5% to 40%, up to 40%. When it comes to oncology, for example, Spark NLP can achieve 84%, while ChatGPT can achieve 45%. So on some entities like modifiers, direction, laterality, gender, etc., these are all close to Spark NLP, but it's still less than 5%. But the biggest difference is on the granular test like oncology, which means that Spark NLP makes half of the errors that ChatGPT does, which means that it is right now making like attacking granular problems much better than ChatGPT can does. For the ICD-10 CM resolution, looks like they increased the precision, they increased the recall at GPT-4, but so they can return more entities and more code, but the truthfulness is very bad over there. But in GPT 3.5, it can return less entities, but much better ICD-10 resolutions. But if they change ICD-10, like if ICD-10 terminologies change tomorrow, you will end up with zero right now. You will not be able to use these models, right? And then you will need to fine tune it again. So there is that's why training, fine tuning these models is quite time consuming and costly, right? So in Spark NLP, our accuracy is already about 90%, by the way, on these resolvers. We are going to share all these results, by the way. If you check this repo, right, like under the slide, like go to Spark NLP workshop before academic LLMs in healthcare. We will share all our results over there. While you are watching this video, you will be probably able to see all the notebooks and even the data sets that we use for benchmarking. You will see over there. And then adverse drug reaction. In Spark NLP, we have 45 different models, and then they are all around 85 to 88 different, 88% when it comes to adverse drug reaction detection. ChatGPT can only achieve 72%. So which means that there is a 15% gap compared to ChatGPT versus Spark NLP. So let me wrap this up. LLMs today are amazing tools, right? We like it. We use it every day, and it's a great automation tool, making like removing the that repetitive, like taking all these repetitive and laborious tasks and then automate them. And it's quite if you know how to use it, but they are not reliable data abstractors. And can still be used in healthcare settings, by the way, but it's more for repetitive tests like note summarization, dictation, patient profiling. These are the tests that are usually taking more time rather than interacting with the patient. And then we need to find a way to deploy all these solutions on-prem. Of course, there will be lighter versions available in pretty soon, probably, but maintaining this, fine-tuning this are quite costly and then time-consuming and requires expertise. And then it's not a trivial task, right? So LLMs hallucinate. It's clear. We already proved that, right? And then may fabricate incorrect results. And then, like the worst part is, it's quite confident. So which means that you may never know if it is fabricating wrong information. So you need to check again and again. Even if we get a truthful, perfect large language model in the near future, the truth may change from one person to another. You can say you one thing might be true for your use case, but in my use case, I wouldn't follow that path maybe to solve my own problem. So that's why the LLMs cannot attack all of them with zero shot. So you need to maybe fine tune or prompt tuning like they call it in context learning. You need to excel on these domains to get what you need. And ideal solution may be guardrailed by explainable deep learning and machine learning models, knowledge graphs, and rule-based system, because it needs to be able to control it. You need to be able to add your own rule, remove different rule, like, and then stop doing something that is wrong, and and then improve it further to accomplish what you need. So, like, that is the ideal situation, and then it could still be used for repetitive and laborious tasks, but when it comes to granular data abstraction by high precision models, for the high precision, like in the test that requires high precision, you should still need to be able to use granular models that I explained in my presentation. And then the last one is use another way of using LLMs is as a smart assistant, so that it can convert the spoken like natural language into some commands or some queries, so that you can query your own created data set, so that ChatGPT and JetGPT kind of frameworks plus granular deep learning models, classic models can still be used, should still be used in the same framework, in the same environment to achieve what we need, so that we don't harm, we don't breach the sensitivity of our data. I hope you enjoyed my talk. You'll get the recordings and then the notebooks, of course, and then I hope you enjoy rest of the NLP summit. Thank you.